Okay, welcome back to the fourth video on how to model multifamily buildings in Energy Pro. In this example, we're going to go over the zone level and room and the assemblies for each of the rooms. So in our last video, we went over the HVAC system level icon and how to model different systems that serve different portions of our multifamily buildings. So when we right click, we will add a zone, and that'll give us our zone icon, which we can see here, and a general information tab will appear, and we're going to put in the level and make sure that's consistent with the floor number. I've done that with all the floor levels zones, so for the sake of time we can just keep this we'll just look at floor level 1 and floor level 2 and floor level 5. So floor level 1 has the correct floor number and level. Floor level 2 has the correct name and floor number, and floor level 5 has the same correct floor number. If we had a consistent building assembly throughout our building, we could use the multiplier in the zone level here for vertical. So since level 3 and level 4 and level 2 are all the same, have the same consistent assemblies, we could have just said the vertical multiplier could have been 3 and removed the floor level 3 and floor level 4, and then said that this floor number here would be the top level, or actually the bottom level 2. But again, this vertical multiplier will push it out to level 4. Okay, so in this example, this is going to be a single level zone breakdown. So after we've filled out the general tab, we're going to ignore the lighting, mechanical, and schedules, as these are all for Title 24 compliance. So if you are doing Title 24 compliance, you will need to make sure you have this information included. This is mostly related to brand new buildings. So once we have our levels built out, we're going to right click and add a room, and this room icon will appear, and we're going to put in information about the general floor plan. So this is going to ask us for a name. We said it's a common area, and then it's going to ask us for an area. So in our takeoff drawing here, we see that it's 24 feet times 50. So if we bring up our handy dandy calculator here, we can get a calculation for our floor plan. So I have 24 times 50. We have 1,200 square feet. Go ahead and model that here. We have 10-foot ceiling height. Our building is existing, and it is built in 1945. We can ignore the winter, indoor, and summer indoor temperatures. We're going to ignore the infiltration tab and skip straight to the occupant tab and put in the residential section the number of kitchen and the bedrooms. Since this is a common area, we don't have any kitchens or bedrooms. But if we go straight to our level 2 room, we can see that we have 5 bedrooms and 5 kitchens. And this is going to be the same for the 3rd and 4th levels. In our 5th level, we have 10 bedrooms instead of 5, and 5 kitchens. We have 2 bedrooms instead of 1 bedroom apartments. Going back to the general tab on our floor level 1. Okay, occupant 0. Now we're going to put in information about our walls. So that's just a right click, add exterior walls. And I'm going to do that for each of my elevations, my front, my back, and my left side and my right side. If we designate the front, back, left side, and right side simply by looking at where the front door is. The front door is facing due south, so that will be our front, and our back will be facing due north. So in Energy Pro, we're going to say our front exterior wall, and it's facing orientation due south. And the existing assembly, we should have that from the assessment. And let's say in this example we have a 6-inch concrete wall construction. Okay, so I'm going to do that for all of my elevations. I'm going to do a left side. Put in that area, which is 50 feet times 10-foot ceilings, which is 500 square feet. The orientation is west. Okay, and we can ignore the tilt because it's just a straight 90-degree wall. Okay, and I'm going to right click and add windows and doors, just like I did with this one. Right click, add windows and doors. And again, we can see that this is our front orientation because we only have a door here. We only have windows on our left side, right side, and back walls. Okay. And I'm going to do this for all of my elevations, or all of my rooms, for each of the different floor levels. So I went ahead and built out all the exterior walls without the naming conventions, but they will all be consistent. Front will have a due south orientation. The left side will have a due east, excuse me, due west orientation, and the back wall will have the orientation of due north, which is already the default. And our right side exterior wall will have an orientation of due east. And in each of our orientations, again, they will have windows modeled into it. We'll also model in the exterior floor, and that's just an add. It'll be a raised floor or a slab on grade. Okay. And if, for example, you have a building has parking garage structure as the first level, you would model your first floor level as floor level 2, and you would say that this raised floor was actually raised concrete. And we'll go into the existing assembly libraries in a second. But for the sake of building out your building tree for your rooms and your assemblies, we're going to be looking at our exterior walls and our raised floor for our floor level 1. And we added in windows and doors for each of these assemblies. Our second, third, and our fourth levels, we're not going to have any partition walls or assemblies modeled in. We're just looking at exterior thermal boundaries. So we only have exterior walls for the second, third, and fourth levels. On the fifth level, we will see a roof, so we have that modeled in. And that's just, again, a right click, add roof. Okay, so once we have our assemblies modeled for each of our floor levels, we're going to go into look at first the windows. And we're going to keep a naming convention that will help you when you're looking at your takeoff. So as you can see in this example, this analyst gave each orientation a letter, and with each orientation a window by a cross mark or an X, and with each X has a call out for the elevation, side, and its dimension. So we will go ahead and in our model keep a rhyming convention. So as you can see here, this is the front elevation, and this is C1 and C2. So this is the front orientation here, this is C, and 1 and 2. And it should go from top to bottom, left to right. Top to bottom, left to right. So that way when you're looking at your model, you can see keep a convention or a way of looking at the model and not get lost. So once we have our naming put in, we'll put in the square footage. We said it was a 4x4 window, and that's 24 square feet. It's existing, and the fenestration type. We'll go into the assemblies in a second. So once we have our windows, our walls, our floors, and our roof assemblies, all components all modeled into our rooms, we're going to go in and make sure that these assemblies are per what our analysts found. So earlier we said that we knew that this wall was a concrete wall, so we'll go ahead and for each of our assemblies change the type by clicking that X and finding the naming here. If there's an assembly that you don't see in this list, you can always hit this little plus mark here, and that'll create a new line item for you to name the type of assembly you found. So let's just say this is existing wall per analyst. And you can import the wall, and you can find the different construction types on the list here on the left, and you can pick the description for each of the construction type. And these are all based on California's Title 24 Chapter 6, so they're not, if you're used to ACA or an ASHRAE level analysis, you won't see these assemblies here, those assemblies in this library. And it's the J4 library, or the J appendix, if you're familiar with Title 24. So in our example, so that's just if you're building an assembly that you don't see in this list. Okay, so we have again our 6-inch concrete wall, and we'll be given defaults based on the commission here. And if there was any added interior or exterior insulation, you can model that in as well. For example, let's say you're dealing with a steel framed wall or a wood framed wall. You also have the assembly types here. So again, this is a wood framed 2x4 wall with no insulation. And if you didn't see the wood framed here, there's also metal frame wall assemblies as well. You can also import them if you don't see them on the list for metal stud assemblies. Okay, so let's leave that as our 6-inch wall, concrete wall. We have that for all. We'll do that for all of our elevations. So in this example, we said that it's just a raised crawl space underneath the common area, but it's not insulated, so I'm going to default it as a R0 floor with crawl space. And you can see the information here. We'll just go ahead and OK out, and that'll change our existing assembly. And this number here, the area square foot, should be consistent with the room area here. Okay. And that goes for our front, back walls, so this should be 240. Front and back are the same. Left side and right side should be the same. And we're going to go ahead and change our assemblies as well. Make sure everything is consistent. I said back was due north, right was due east. Okay. And that pretty much wraps up our common floor level. The second floor level, they'll all be pretty consistent. And again, the square footage of each area should be and the naming convention should be consistent with what you have modeled up here. So I will model front, left, back, and right for all the different levels here. So that we already went over how to model each of the walls and each of the windows, so we'll go ahead and skip straight to our roof assemblies. So looking at the roof assembly, you're going to right click, add roof, and put in the square footage based on the actual area, which should be consistent across each of our buildings, floor levels. So they all should be 1,200 square feet. Okay, we can see they're all 1,200 square feet. So our roof should be 1,200 square feet. It's existing surface type, and in this example, we're going to say it's a flat roof concrete wall. So again, we're going to hit the little plus, add a copy here, and say flat roof and go into the import, click on that, select the roof. We're going to look for our concrete wall here. Okay, we're going to say it's fireproofed at 6 inches. Okay, we're going to leave the orientation at 0 and the tilt at 0 since it's a flat roof. We can go ahead and name this. Okay, but let's say you had an actual flat roof that had wood rafters, then you would go ahead and change that to your cathedral or your roof, your R0 roof attic. Well, depending on how much insulation is in there, you're going to look at your analyst's ASHRAE level 2 assessment and see what it is, the level of insulation, if it had an attic. And if you're dealing with pitched roofs on some multifamily buildings, you'll go ahead and model those as roofs as well, and if they're cathedral ceilings or not. So again, this is a flat roof concrete. We're going to leave that there, and let's go ahead and jump straight to our windows. So we went in our walls, we went ahead and right clicked and added windows based on the elevation and the naming convention, and we're going to put in the square foot. So we said we had a 4x4 window. We're going to keep these typical for all our elevations. And the fenestration type, you just go ahead and click in the little section here. And if you're dealing with an existing building, it's most likely you're going to have to use one of these defaults. But if you're dealing with a building that already has window just replaced, it's best to try to find that NFRC sticker for those windows, National Fenestration Rated Council rated window, and you can look it up in the NFRC website database, or if there's you can find it in this naming here, or you can just make a copy, name it your window, change the NFRC labels, and put in those values according to that sticker that you found. We're going to use default single pane clear windows in our example. Okay, so that pretty much wraps it. And one thing we need to just quickly note on, same thing with windows. If you're dealing with a skylight, you're going to right click and you're going to add a skylight. Just like windows, you're going to set up the area and the surface type and the fenestration and the skylight type based on what the analyst found. Okay, it's 10 square feet, and we'll leave that as double non-metal clear. Okay, so we should have all our systems, all our domestic hot water systems, our plants, HVAC systems, and the levels they serve, all modeled out, as well as the different assemblies. So in our final video, we're going to go over the different calculations you can perform in Energy Pro and how to report on those different calculations. Thank you for watching.